Good morning, students. Students, this lesson is of class 8th for the subject of physics, topic sign convention for the measurement of distances and formula for the spherical mirror, which is covered in chapter 7, reflection of light, given on page number 165 of your physics textbook titled Concise Physics by Selena Publications and is being submitted to you on 14th December 2020. Students, to specify the position of image and object, we will follow certain set of rules according to which all distances are measured from the pole of the mirror taken as origin. Students, this origin is same as we had in case of graphs. We are having an origin on a graph paper also when we draw a vertical and a horizontal axis. So the meeting point of vertical and horizontal axis is known as origin. So students, similarly, if you are having a concave mirror, then the pole will be acting as a origin such that all the distances towards right side of the pole will be taken as positive, while the distance taken towards the left side of the pole will be taken as negative. So students, all the distances are to be measured from pole. This is our first point. Coming to the second point, the distances measured along the principal axis in the direction of incident light are positive, while those opposite to the incident light are negative. So students, what does it mean? It means that if we are having a lens, if we are having a mirror, see, now suppose I have drawn a concave mirror such that its outer end is silvered while the inner end is polished, and if I draw a principal axis. Now students, if a ray is incident on the concave mirror, see the incident ray, the direction of incident ray is towards right side. So the distances taken in the direction of incident ray. So the direction of incident is towards right. So that means the distances over here will be taken as positive. We'll take all the distances positive in the direction of incident ray, while students, we will take all the distances negative if we talk about all the distances taken in opposite to the direction of incident ray. The incident ray is directed towards right side. So all the distances in the direction of incident ray will be taken as positive, while all the distances taken on the opposite side of incident ray will be taken as negative. This was the meaning of point number 2. Now coming to point 3, the distances above the principal axis are taken positive and those below the principal axis are taken as negative. So it means that all the distances taken above the principal axis. That means if we take the distances in an upward direction, whether on right or left side, these distances will be taken positive, while the distances in a negative direction, in a downward direction, whether on left or right side, will be taken as negative. So all the distances in downward direction will be taken as negative, while that taken in upward direction will be taken as positive. This is the meaning of point number 3. Similarly, students, now we'll be learning about the formula for the spherical mirror, which we'll be doing in the numericals also. So students, the formula here is 1 by V plus 1 by U is equal to 1 divided by F. So 1 by V plus 1 by U plus 1 by V plus 1 by U is equal to 1 by F. So what is 1 by F? It is equal to reciprocal of V plus reciprocal of U. Now the question arises that what is this V and what is this U and what do we mean by F? Students, V is the distance of image from pole of the spherical mirror. By spherical mirror, I mean both the types of mirror, that is concave and convex mirror. While U, small u, it is actually equal to distance of object from pole of the spherical mirror. And F is the focal length of the spherical mirror. Now students, coming further, usually the object is placed on left side of the spherical mirror. Whenever we have drawn spherical mirror in all the cases of ray diagrams, students, in all the cases of ray diagrams where we have placed the object, we have placed the object always on the left side of the mirror. Whether you are having a convex or concave mirror, the object was placed on the left side of the pole. That means the distance u will be taken as negative. So u will be taken as a negative number. While students, u is taken as negative, and if the image is formed on left side, then v is also taken to be negative. While if image is formed behind the mirror, then v is taken to be positive. What does it mean? It means that if the object is placed in front of the mirror and image is also formed in front of the mirror, then the distance v will be taken to be negative. While if the image is formed on the right side of the mirror, whether downward or upward, the distance between pole and this image is v, and if the image is formed on right side, it will be taken, v will be taken as a positive number. So students, coming to the third point to be discussed, if focal length, that is f, is lying on left side of spherical mirror, then it is taken to be negative, and if it is formed on the right side, then value of f is to be taken positive. Students, just see the ray diagrams given to you last week. You will see that in case of concave mirror, focal length is situated on the left side. Thus, we will take focal length to be negative in case of a concave mirror, while in case of convex mirror, focal length is drawn on the right side. See the ray diagram which was done last week, and then we will see that for convex mirror, focal length will be taken as positive. So students, for concave mirror, focal length is negative, and for convex mirror, focal length is positive. Now coming to the next topic, and it is a very important topic. It is named as magnification of spherical mirror. Magnification of spherical mirror. So students, how to define this term magnification? Magnification is defined as the ratio of length of the image to the length of the object. And it is denoted by a letter small m. Mathematically, it can be written as height of object divided by height of image. And in numericals, I will write it to be HI divided by HO. HI stands for height of object, while HO stands for height of object. HI is height of image. HI stands for height of image, while HO I have taken to write it as height of object. Students, there is one more formula. There is one more formula for magnification, and that is minus V by U. M can be written as ratio of minus. We have to put a sign of negative here. Minus V by U. Now students, this magnification, it is just a number and it does not have any unit. It do not have any unit. Magnification does not have any unit. Two things which you have to keep in your mind is, if image is real, that is, if it is real and inverted upside down, then value of m is taken to be negative. Students, magnification comes to be negative for a real image, while if the image is virtual, then value of m is taken to be positive. We have to remember these 2 points for numerical purpose also. Real image means m is negative. Virtual image means m is positive. Students, for an enlarged or magnified image, the magnitude of m is always greater than 1. This fact is also to be remembered. If you are having an enlarged or magnified image, the magnitude of m is greater than 1. Students, the word magnitude means only the numeric value. That means you are not supposed to take the sign of positive or negative. Suppose I say that magnification is minus 3. So magnitude becomes, what do we mean by magnitude here? Only 3. Don't take the sign of minus. Minus means image is real. 3 is greater than 1. So the image is, minus means image is real and it is enlarged or magnified. While if it was plus 3, plus means virtual image, but again enlarged or magnified. Magnitude means only the number. Similarly, for a diminished image, magnification is less than 1. The value of magnification, the magnitude, is less than 1. And for an image of same size as that of object, the magnitude, I repeat, the magnitude of magnification is equal to 1. Now students, I want to discuss 2 questions with you, and listen carefully. You have to answer it in your physics notebook, and with answer you have to give a reason for your answer too. So kindly listen and see this question. Question number 1 is, what will be the magnification for the image formed in case of plane mirror? You have to give the value, the complete value of magnification for the image formed in case of a plane mirror. Question number 2 is, what will be the value of magnification if the object is placed at center of curvature in front of a concave mirror. You have to write down the value of magnification in case of plane mirror and in case of a concave mirror when the object is placed at center of curvature. So students, kindly pause this session and write down the answer and then resume further to check your answers. Now students, let us see what your answers are coming. So for question number 1, when the object was placed in front of a plane mirror, students, here our magnification will come +1. Why plus? Because in plane mirror, image formed was virtual, as we have done in first exercise also. In the characteristics of image formed by plane mirror, we have already studied that image formed is virtual and erect. So the sign should come plus. And one more important characteristic was that the size of the image is equal to size of the object. So that means the number should come 1 here. So that's why our magnification in this case of plane mirror, it will be +1, students, as the image formed is virtual and is of same size as that of object. Coming to question number 2, when the object is placed at center of curvature in front of a concave mirror, students, here we get a size, same size as that of object in case of the image. So image is having same size as that of object. But what kind of image was formed? Very good. It was a real image, as we have done in case 2, in case of concave mirror last week also. Hence, the size of the image is same as that of object. So magnification is -1 in this case. Yes, students. Now, in this part, I'm giving you some values of magnification. You have to name the spherical mirror and the position of the object relative to the position of the spherical mirrors. So in this table, you can see the values of magnification given to be as -0.5, 1.5, -1.5 and 0.2. So there are 4 parts, 4 different values of magnification. First is magnification is -0.5. Second, magnification is +1.5. Third, magnification -1.5. And fourth, magnification is equal to 0.2. Students, you can complete this table in your physics notebook. You have to name the type of spherical mirror used such that such values of magnification can be attained, and also write the position of the object. That is, where is the object placed? Kindly pause this video and write down the answer and then resume it further for the explanation of each part. Yes, students, I hope you must have completed this by now. Now, students, let us understand how we have done this question, how we have to apply the concept studied last week in this question. Now, in case of a convex mirror, we were having only one case, that the object, wherever is the object placed, the image formed is virtual and diminished. Virtual means it should be positive. The value of magnification should be plus, and its value should be any number less than 1. since the image formed is diminished. So in whole this table, in all the questions, all the parts, see, where do we have magnification less than 1 and a positive number? So I think so it is 0.2. So in case fourth, so students, in fourth case, what shall we say? We can say that mirror is convex mirror and the object is placed at any distance in front of a convex mirror. Similarly, now coming to the first point, minus 0.5. Negative means real image. Students, real image is always formed in concave mirror. So for first part and third part, mirror is concave, and for fourth part it is convex. This is clear to us. Now coming to first part again, minus means real inverted image, 0.5 means a diminished image. So real and diminished image is formed, and it happens when it is the first case which we draw last week. It is happening when object is placed beyond center of curvature, that is capital C. Object is placed beyond center of curvature. Coming to the second question, magnification is 1.5. Positive number, that means virtual and upright image is formed. 1.5 is greater than 1. So that means a magnified image is formed. Virtual, erect, and magnified. It happens only in concave mirror. Students, in both convex and plane mirrors, you cannot form a magnified image. So for formation of magnified image, we have concave mirror. So the object here can be placed between pole and focus. This was the last case which we draw in category of concave mirror. In case 3, magnification is minus 1.5. Minus means real and inverted image is formed, and 1.5 is a number greater than 1. So students, according to sign, it is a real image, and according to number, it is a magnified image. So real and magnified image is formed when the object is placed between center of curvature and focus of the concave mirror. Part 4 we have already discussed above earlier today only. So students, with this I come to an end of this interactive session. Kindly practice the ray diagrams once again and observe where the value of V and F are negative and in which case they will be taken as positive. Revise all the topics of magnification done today, as it will be required in doing the numerical based on mirror formula. What is mirror formula? 1 by V minus 1 by U is equal to 1 by F. So students, spherical mirror, the formula for spherical mirror is, it is 1 by V plus 1 by U. Plus, it will become minus when you will be putting U as a negative number. We will be always taking U as a negative number. It will be taken negative. We'll be taking minus U. Why? Because the object is always placed on left side. So students, 1 by V plus 1 by U is equal to 1 by F will be written as a mirror formula. And the numericals of this topic will be done next week. Until then, kindly go through all the topics done last week as well as this week. So students, kindly revise all the topics so that it can help you in numericals also. Thank you, children.